Hello Mendix community, welcome back to the Learn Mendix with Rachana series. In traditional development practices, we start by learning the language, understanding its syntax, and solving various simple problems before developing an application. However, with Mendix, a low-code platform, we often jump straight into creating POCs and applications. While Mendix encourages citizen developers, tackling complex applications without a solid grasp of Mendix fundamentals can hinder our full appreciation of the platform. Without wasting much time, let's explore what's in store for us in today's episode. The agenda of our today's session is to understand our problem statement, check out on possible solutions to crack the problem. Now that we have understood how to solve the problem, let's try to solve it in Mendix. At last, let's analyze our journey of solutioning this problem statement. Today's problem statement is to determine if the number is a palindrome. What is a palindrome? A number that remains the same when it's reversed is called a palindrome. Few examples are 13221, 1221, double line. Let's see what are the methods of checking if the number is a palindrome or not. As per definition of a palindrome, the reverse of a number should be same as the number if the number is a palindrome. Most common method in mathematics to solve this is called divide by 10 method, where you take the highest placed digit and start placing it to the lowest digit. Another hack to do this would be to consider this number as a string and do string reverse. Let's see how to implement both of these methods in Mendix. Without wasting much time, let's start developing both the methods in Mendix. I'm using Mendix version 10.11.0 for this. Let me just quickly show what is the domain model required to develop this. I'm using an entity called palindrome number. Number field is an integer and there's a validation that the number should be greater than 1 and a palindrome attribute to determine whether the given number is a palindrome or not. Method is just an indication to know which method we have used and solve the results. Let me quickly get into the page where the calculations are going to happen. So as a user will be able to enter a number and click on check. When clicked on check, currently this microflow is of a method 1. In the method 1, the formula used is initially we are creating a variable called temp, where temp is equal to the number. Then we are creating a variable called reverse. Reverse is equal to 0. And then we iterate over a while loop where temp is not equal to 0. Here we are calculating a remainder. Remainder is given by temp mod 10. Reverse is equal to reverse plus remainder. And temp would be changed to temp divided by 10 again. So at last what we are checking is if the reverse and the temp are equal. If the reverse and the temp are equal, then it's a palindrome, otherwise it's not a palindrome. So the formulas or the functions used in order to get these values is $temp mod 10, like previously explained. Mod is a function which is used in Mendix to get the remainder. It's a simple arithmetic function here where reverse into 10 plus remainder is done. Again here it is a simple division function. However, along with the division function, we have used a function called floor. Why is floor used? There are multiple functions available like round, ceil, floor. Why did we use floor only instead of round or ceil? Round or ceil usually changes the number, but floor function does not change the number. For example, if the value was 10.5, 10.56, floor gives a value as 10. However, round would give it to me as 10 point, it would be giving me as 11, and even seal would be giving me as 11. If instead of 10.56, if it was 10.46, then round would have given me 10 and seal function would have given me 11. That is how all three arithmetic functions work in Mendix. Here, for our calculations, we do not want the value to be changed. That's why we are using floor function. This is very important in this method. If you are not using this floor function, you will not get right values. Let me quickly run this and show. Application ran successfully. Let me just quickly navigate and test it. Let me enter a random number. Is this a palindrome? No. So I got an information that this is not a palindrome, and this has been done via method 1. Let me now enter a valid palindromic number 1221. Yes, the answer gave me that 1221 is a palindrome number. Let us just quickly check the stats of this. So for the first number it took about 30 seconds, and for the second it just took about 15 seconds. So based on the length of the number, the time based on the length of the number, the program took time to run. That is because of the formula, the way it is. You are going to take units and you are placing it into the respective numbers. We have completed the testing of the method 1. Let us see how to implement method 2. I've changed to the method 2, and let me just maximize to see what method 2 is. Method 2 is reversing and converting in the given number into a string. How am I doing this? First, I'm calculating the length of a given number. Then I'm creating a number called, string called a string palindrome, which is the string of a given number. Then this is a count, which is used as a variable for the while loop. I'm creating placeholders called as left string and the right string. These are initially with a value of an empty. Then this while loop is going to run as long as length. So basically the simple concept is half of the number should be similar to the other half of the number. That is why we are doing it as length divided by 2. So this loop is going to run for a count value of length less than or equal to less than length divided by 2. Like you can see, this colon sign indicates a division activity in Mendix. We can write the colon, or we can also write it as div. Both does the same functionality. So what am I doing first? I am changing the variable where I am taking how does a substring function work. So we are taking the string palindrome. So the number is taken here, count. Initially count was set to 0. So we are telling it 0, 1. 0, 1 gives me the first value of a given number. Okay, so I am storing that in the left string. Then I am doing count plus 1. Next, I am calculating the right string. A right string is what? Right string should be the last digit of my number. That means, how do I get this? Again using the substring function, where I am doing substring of the number comma length minus count. Here count is equal to 1, so length is probably 3 or 4, then 4 minus 1 would be 3 to 1. So how does a substring work? Substring will tell the exact location. So currently this is a value which the substring should happen on, and length minus count would be the starting position, and this 1 is the number of values it should connect after the starting position. In our first case it was 0, but in our second case it is the last but 1. So here we are checking if the left is equal to right. If left is equal to right, then we will not do anything. However, if it is not equal to right, then we declare that it is not a palindrome. And at the end, we check if the given value was a palindrome or not. Based on that, we generate the results. Now let's quickly run this and check how it works. Again, let me take a same example, 1, 2, 2, 1. Here it gave me as a palindrome and it gave me in the method 2. Let me just again write a random number and see. So 87990812 is not a palindrome. Ideally, in this method, let me just analyze how much time it takes. So first number took about roughly 12 seconds, and the second one took about roughly 10 seconds again. Comparative to the first one, definitely the speed, there's an improvement in the speed. That is because the loop value is gonna run to half of the length. So it depends on how big the length is, and the while loop runs only till half of the time, whereas in both the methods, using method 1 we got results in 17 seconds, and we completely used arithmetic functions. We learned about floor functional and the division mod in this method. Including method 2, though method 2 seemed very complicated compared to the method 1, we simply used string functionalities here. We learned about the substring functionality, and this method took about 12 seconds to fetch the answer. Concluding, we could easily use arithmetic functions present in Mendix to determine if the number is a palindrome or not. Also, we could easily solve the problem by understanding how substring works. Thank you for watching so far. Please let me know which problem statement I need to solve next in comments. Thank you.